understand the types of forces we measure and experience on a daily basis, let's define first what a force is. If we use a dictionary, we see several options for definitions. In the realm of science, we are not looking at armed forces, but rather the energy exerted to cause a change in motion, whether that's speeding an object up, slowing it down, stopping it, starting it, or causing it to change direction. To simplify it, we can say a force can be a push or a pull exerted onto an object. We measure forces in the unit of newtons. Before we jump into the types of forces, let's look at the two categories that they fall into. Those two categories are contact forces and non-contact forces. Contact forces are forces that directly touch the object. Non-contact, as the name implies, are forces that do not make physical contact with an object. Let's start with contact forces and begin with applied force. Applied force is the force we are all familiar with, whether you're kicking a soccer ball, pushing a shopping cart, or even moving and clicking your mouse to press play on this video, are all examples of applied force. Friction is another contact force that works by opposing motion between two surfaces. A good example of friction in action can be found in the brakes of a car. The mechanism of coming to a stop requires the brake pad to rub against the brake rotors. As the brake pad and the rotors make contact, the kinetic energy of the moving tire is transformed into heat and sound, and the car slows down. Friction is also useful in daily activities like walking. The tread on the bottom of your shoe interacts with the surface below you. The friction force opposes your motion and prevents you from sliding your foot too far back and allows you to push off the ground and continue with your next step. This is why it's easier to walk on concrete than it is to walk on ice. This next force may have an uninspiring name, but it's probably my favorite force, and that is normal force. It too is another contact force. Normal force is the support force exerted by a surface that opposes the force of gravity. This force allows you to place objects on a desk. It allows you to climb the stairs, and it prevents you from falling to the center of the earth. As gravity is pulling you downwards, normal force of a surface is pushing upwards with equal and opposite force. Tension is another contact force, and it is a pulling force that's transmitted through ropes, strings, or cables. When Tarzan is swinging on the vine, he is experiencing the tension force provided by that vine. Same with Spider-Man. Spider-Man is using the tension force from the string of his web. In a real-life situation, you experience tension force whenever you ride in an elevator. An elevator is pulled upward via the cable inside the shaft. You may even experience it walking your dog. As your dog lunges to chase after a cat, the leash provides a tension force that pulls you forward. Gravity will be the first non-contact force that we talk about. I bet you've heard of Isaac Newton and the apple falling on his head. Now, we could say that's all that gravity is. It's a downward force, but let's broaden our horizons and let's define gravity as a force of attraction between two masses. Why that apple fell to the ground is due to the attraction force between the apple and the earth. The earth is much larger than the apple and is going to have a stronger pull on it. When the apple breaks away from the tree, it is forced downward towards the surface. This is why you and I are somewhat glued to the surface we walk on, and why we don't float around. We are experiencing an attraction force from the earth that is pulling us. This same force is the mechanism that orders our solar system and why we orbit the sun. Magnetic force is another non-contact force that is quite complex. It is a force exerted by a magnetic field. To start, let's look at a magnet. Each magnet has two opposite poles, north and south. If we were to draw the invisible magnetic field, it would look something like this. These two poles have an attraction force between opposite poles and a repelling force with the same poles. In other words, north attracts south, but north cannot attract another north. This is why magnets tend to jump or push away from each other when you try and place the same-sided poles together. So what ends up happening is this magnetic field provides a push or a pulling force that can move magnetic materials and electrical charges. You can find magnets that you place on your refrigerator. There's magnets in your speakers and your headphones. Even the earth has its own magnetic field and is what's responsible for the movement of a compass. Electrical is the last non-contact force that is also quite complex. Very similar to the magnetic force, electrical forces act with an attraction and a repulsion force, or a push and a pull, but this time with charges. Objects become charged when they lose or gain electrons, which are negatively charged particles. There is an attraction force between opposite charges, so a negatively charged object is going to attract or pull a positively charged object, and a positively charged object is going to repel or push another positively charged object. This attraction force between charges comes in handy when we talk about circuits and how plugging in a battery turns the light on. The battery provides the electric force, and the wires act as a pathway for charges to flow from the battery to the light. Well, there you have it. We know that a force can be a push or a pull that changes an object's motion. A force is categorized by either a contact or a non-contact force. We went over 7 forces that we can experience on a daily basis that impact us in ways that we may have never thought about before. So the next time you're watching a Smithers Science video, start taking notes on what forces you are experiencing and see how many you can find.